messing around with the double pancake coil in that anonymous post that caught my interest. So what's happening is you got two pancake coils here made of coaxial cable for now. They're all going the same way, basically. First one starts on the outside and goes around to the center. Then the second one starts in the center and goes around the outside. So this one starts this way and ends this way. It's actually one big coil, but stacked on top of each other in two layers. Now, you got to connect the middles, but you want to cross the middles. Right, so the inside goes to the outside, outside the inside. Now, I don't have it like that now. I have it like one coaxial cable where the middle attaches to the middle and the shield attaches to the shield. Okay, just to show the difference. Now, in this configuration, I'm using a signal generator and I'm putting signal into the center pins and I'm reading both sides in and out. Now on this one, as you would expect, a regular sine wave, and it's actually inducting real good because 731 in, 737 out. When I use my multimeter, it actually reads the exact same. So 100% transfer in there. So I'm happy with that. But anyway, this configuration is normal. This is what I get when I use any other transformer like this. Now, what I mean is, if I short the outputs, boom, and boom, everything goes away. Zeros. Open it up, boom, everything's there. Shorting the outputs transfers 100% onto the primary. Okay. Now, however I hook this up, if I hook it going up in the primary, in the secondary, short, one, short, it always does the same thing as this. Okay. There's no way to like change that. But this one's interesting because those schematics online, I think it's hard because it's a two-dimensional drawing and I'm doing a three-dimensional thing with coaxial. It's not really the same. Now if I switch them, go to the top and bottom. So on the inside, the center conductor goes to the shield and this center conductor goes to that shield. They're switched. Okay. Now we get much less, obviously, but let's turn this down until we could see the waves. Now, as you see, we have a complete reversal. There's just about a complete reversal. I think it's not 100% complete because my coils are a little offline, as you see. They're not perfectly lined up, but it's the best I did with my burnt fingers and a couple hot glue sticks. Anyway, that's interesting. Now watch what happens. Now it does what a coil does at resonance, which is interesting. So now I'll short the secondary. Now watch the primary voltage. We're at 68. Shorted 75. 68 not shorted. Shorted 75. It's actually self-inducting back into itself, almost like a reversal of back EMF. So, but the downfall is that they're like not producing much at all. You know, we're talking about a couple dozen millivolts, nothing to write home to mom about. But we could do this at low frequencies, so we don't have to be up at resonance in 40 kilohertz where you can't do nothing with it because you can't pump any amperage into it. So I don't know, maybe there's a chance with a configuration like this you'll be able to pump pulses through and collect it on the other side, like AC, and collect it on the other side, and while you're doing that, pulling a load off the secondary helps what you're collecting. I don't know, but either way, it's a fascinating coil.